It is January 24th in the year of our Lord, 1923. And I, Father Marcus Littleton, shall now commence reading aloud the first of the spiritual resurrection passages. Kanda. Est Rada.
Hey Dr. X, I just ran the experiment. Can you tell me what you think about this data? So I got
milliliters, 3.84. 1 milliliter, 4.11. 2 milliliters, 4.83. 3 milliliters, 5.22. 4 milliliters, 8.35. 7 milliliters, 14. 8 milliliters, 14. 9 milliliters, 14. 12 milliliters, 14. Hello again, everybody. Today we're going to do another titration. I know how much y'all love these.
What's wrong with you, bro? You tripping?
But this time we're going to use a pH probe so we can actually make a titration curve and we can figure out exactly where that equivalence point is. We can do a first and a second derivative. We're going to use our phenolphthalein indicator again, so we're going to see a color change. But really that's just to show us where's the end point, where's when we see the color change, and how that's actually different or how that comes after the equivalence point. So the first thing you're probably going to want to do is, if you're the first person on the pH meter or the pH probe, is you're going to want to calibrate it. It only needs to be calibrated once per day, but if no one's done that yet, if, like I said, you're the first one on here, you'll have to do that. Get a waste beaker, get some DI water, just give that pH probe a little rinse, and then I'm going to come in and just dab away that excess water. I don't ever want to rub or wipe or use a lot of pressure, because there's a glass bulb on the bottom of that pH probe. That's the interface that's going to interact with our ions and record that value. Then you should have your calibration standards, pH 4, pH 7, and pH 10. I'll start with the 4. This arm moves, so I can just take that and put the probe directly in here and then watch the pH. It hasn't been calibrated in a while, so maybe it's gonna stabilize at 4.05. Then I'm gonna push standardize and tell the probe that what it's in is pH 4, and it should reset itself and read now 4.00. I'll rinse the probe off again, dab away that excess water, and then I would just keep moving through. All right, the next thing we're gonna need to do is deal with our unknown so we can start to do our titration. Your unknown is potassium hydrogen phthalate. It's gonna be in the desiccator again in a sample jar, numbered. Make sure you record it, record the number you have, sign it out. And then however much you have in here, you're actually just gonna use all of it. Mass the whole thing into something. Get your 500 milliliter volumetric. I've actually already made the solution and did a sample titration. That's why you can see the volume is down. But you'll have a clean, empty volumetric. You're gonna take that KHP that you masked out, transfer the entirety into here. Make sure if there's any powder left in here, you do a couple rinses, and then fill a little below the mark, mix it, make sure it's completely dissolved, then fill to the mark. This will be enough to do your rough titration and then your actual pH probe titration, and in case you make a mistake and you have to do it a second time, you'll have plenty extra to do that with. And the rough titration is going to be with only 25 milliliters. So I'm gonna get this and transfer it to a separate beaker, because again, I never want to pipette directly from my stock. And the rough titration, we're gonna do exactly the way we've done all the other titrations before. We're gonna use the indicator. And like I said, it's a rough titration. Our goal isn't to be perfect. Our goal is to get an idea of about how much of this it's gonna take for our probe titration. So we have an idea when we start, do we wanna start really quickly with large aliquots, or do we need to go a little more slowly to begin with? I've got my burette, I've already conditioned it, filled it with sodium hydroxide. Note what volume I'm starting at. You know, if you can, shoot for the light pink color. We might overshoot it, that's okay. All right, there we go. So that happened pretty quickly. So I'm gonna look at that and say, okay, this one took about 3 milliliters. When we do our probe titration, we're gonna use 100 milliliters of our unknown solution. So if this was 25, we're gonna use 100, that's 4 times as much. If this took 3 milliliters, I can guesstimate that this probe titration is gonna take around 12. You'll have a stir plate at your bench top. There should be a stir bar on top of that. Make sure you rinse that stir bar, make sure it's clean, and then you can go ahead and introduce that into the beaker with your solution that you're gonna be doing the titration in. And like I said, we're only gonna use a little bit of indicator for the pH probe titration. We can put just a single drop of that in there, and that's gonna be so we can see some color change, and what you're gonna find out is you're not gonna see that color change until actually after the equivalence point. You don't see the color change until the end point, and the end point actually occurs a little bit after the equivalence point. So I've got this ready, I've got to get this set up on here, and I want to start this spinning. I don't want it to go too quickly. I want it to spin fast enough that it's going to mix everything, but not give me a vortex. And then the really difficult part is figuring out how can I take this, keep it all the way it is, and introduce the probe. There we go. And then I can bring this down through. And you probably want to use an entire page of your notebook, because you're probably going to end up with like 20 data points or something like that. I've got my starting volume, 16.10 milliliters, my starting pH, and the color. I can now start adding large aliquots until I get to around a pH of 6. I'm going to add those large aliquots, so in this case probably, since it took me 12, or I'm
English, motherfucker, do you speak it?
expecting 12, I'm going to add 1 milliliter aliquots at a time. So I go ahead and add about a milliliter. What's the volume that I added in this case? Once that reads stable, what's my pH and what's my color there? And I'll just keep going until, like I said, I approach a pH of 6. Okay, and like I said, yeah, we just keep going.
Oh my God!
Okay, so yeah, we're at about 6 right now. So now instead of adding a half a milliliter, probably gonna add about 3 or 4 drops at a time. Yeah, there we go. So we're at about 6.8 right now, and now we're on that upward slope. If I add more than a drop at a time, I'm gonna miss that slope. I'm not gonna have any data points on that. So I'm just gonna add 1 drop at a time. That now we're to pH like 8.7. We're almost to 9, and I'm finally starting to see that pink color. So you can illustrate that the end point occurs actually after the equivalence point. Get a few data points on the plateau, and then you're all done. And the really big thing is you're adding single drops and you're getting as many data points from a pH of 7 to 10 as possible. So yeah, thanks everybody, and like I said, thanks everybody, and we'll see you next week. Where do you want to start from? You're just going to include all that?